Okay, so now that we've done our visualization in our test tubes, what we're going to do is we're going to take the rest of our oil system clean and we're going to add it into the vehicle, and so that we can run this for 15 minutes and complete our oil system clean. So we take this can, pour it directly into the oil, just like that. One can, again, treats up to 6 liters. And now we're going to start the car up and run it for 15 minutes. Now that we've got the car running, we're going to show the rest of our visualization of in our demo with regards to the other product that we're here to talk about. Alright guys, so we'll come back over here. Oil system cleans in the car. We're going to move on to our next product to show you while that car's running, which is our fuel system cleaner. Okay, so our fuel system cleaner, we always want to make sure we know our engine oil is clean. We got to make sure we clean up our fuel system. So what we're going to talk about right now is we're going to talk about multiple problems that we have within our normal fuel system. And when we talk about the problems that we want to encounter first, the most common problem is moisture. And when we talk about moisture, we're talking about basically the condensation that forms due to the air pressure and the balancing of the fuel tank for regulation, and we have condensation and moisture within the air that build up within the tank. Condensation forms on the walls of the tank, and of course as it settles, heats and cools, that condensation builds and sits at the bottom of the tank.
So that's water?
This is water, and fuel we've mixed together. Not really mixed, because one thing we know, water is heavier than fuel. So water sits at the bottom of the fuel below, and this is where the pickup is for our fuel tank. Now the problem is when we have excess moisture in our fuel tank, what happens is it wants to travel around with the fuel. But the problem is that fuel and water don't mix. It's just like oil and vinegar, right? And it leaves all sorts of droplets and plating throughout the fuel system and allows corrosion through the fuel lines. Water will freeze, blocking fuel and restricting performance and fuel delivery to the actual engine. So what we have to do is find a way to actually address this issue. Normally our products or our problem would actually rise like this if it's diagnosed. We would remove the fuel tank, drain it, and of course remove the moisture. However, other products, I know that you guys have seafoam, which we're going to get to soon, but we're going to show you what happens with excess alcohol in the fuel tank, okay? Because our gas contains alcohol. If we get a little bit too much alcohol, this is straight spirit alcohol, rubbing alcohol. What happens is when you introduce a product with more alcohol or excess alcohol builds, it's actually drawn to the water because it is hygroscopic, and you form an excessive layer between the fuel and the water. And what happens is when the alcohol product and water mix together, this hygroscopic fluid is actually more corrosive, damaging with all those droplets traveling throughout the water system and freezing. Okay. Now, again, just like our oil system clean, we have no simple alcohols within our fuel system cleaner. This is a synthetic-based fuel product. It's CTL technology, which is coal to liquid, purest form of fuel known to man. Synthetic, that is our base stock with cleaners and additives to actually help reduce the problems within our fuel system. So what we're going to do is we're going to take a little bit of our fuel system cleaner, about 1 milliliter, and add it to our mixture here with gas, water, and alcohol. And what we're going to see right away is that binding product is binding together with the fuel strictly. It's pure fuel. It will bind with the gasoline that's in the tank. What happens is the mixture at the bottom of alcohol and water, the excess fluids, as this product mixes with the gas and travels with those excess moisture buildup through the fuel system, it starts to form a semi-stable emulsion. What happens is it binds the water and the alcohol together with the fuel for a semi-stable emulsion that can be combusted in normal operation. It also leaves a lubricating layer behind from the pump through the fuel lines, taking all moisture and all problems out of the fuel tank through the fuel system, cleaning that product from the tank right to the delivery of the engine. So now you have less moisture, no moisture, in fact, left within the fuel system to corrode, freeze, or cause poor starts, bad throttle response. That semi-stable emulsion will last as long as the fuel is mixing in the tank with the product. It's good for up to 80 liters of fuel. One treatment seasonally perfect is good because what we're looking for is to get that moisture out of the tank, which occurs on a regular basis. So that's one problem we can solve just with adding even only 1 milliliter with this mixture right here. So see that nice milky emulsion that we get? Leaves that lubricating layer behind. That's a nice lubricating picture that we want to see. Okay, so that'll stay mixed as long as it's in the fuel system. Again, once it settles, if there's excess moisture overnight, long period of rest, it'll come and separate, but as long as it's in the tank, it'll emulsify once the car is moving. So we've noted that that is one problem that we can solve within our fuel tank, within our fuel system clean. We're going to demonstrate exactly what other products do that you're currently using in the shop. So we're going to make the same mixture of fuel and water. Same basis, 50-50, just for a visualization. So again, fuel and water mixed together. They don't mix, obviously, so that's not really true, mixing together, but when they come together, this is what happens, leaving droplets and plating throughout the system, just as in our first tube. Okay. A little bit of alcohol as we had in the same mixture, excess from other products. Same mixture that we're looking at, jelly-like layer in between. Of course, removing moisture, binding it together in a hydroscopic fluid, and you've got that mixture there. So what we have in here is a visualization that we just had there, but we're going to show you basically what you're using right now, which is seafoam. Okay, so seafoam, all these statements on here: cleans, fuel stabilizer, lubricity, freeze, de-icer, and you can use all this for, and this is the product you're using to help clean up your fuel system right now. So we're going to take the same amount of product in a new tube, pipe bed here, and we're going to introduce the same amount that we did of ours, so that we're right on par, 1 milliliter, added to our fuel mixture. Okay, this is our seafoam. We're going to see if this helps actually remove moisture from the system. So it looks to see like it bound with the fuel, but you can't really tell the difference. What happens is when this rocks back and forth, there is no mixture. So this is doing nothing to actually help remove moisture. It's got the fuel mixed together with the seafoam, but the water and alcohol problem is still present. You've still got droplets and plating through the system. So this doesn't do anything to help remove moisture. Okay, so one thing that we do that they don't. Now we're going to move on to the next issue that we want to address within our fuel system, and that's what we're talking about, is resin and varnish. Okay, resin and varnish are due to the oxidation of fuel, and by oxidation what we mean is when fuel ages and it comes in contact with the air, the unburned portions of fuel actually oxidize and form resin and varnish. Resin and varnish, to you normal mechanics, is that brown sticky stuff. It looks like honey. It's almost like what we call the cholesterol of the fuel system. It does happen with age of the vehicle, and does happen with age of the gas that's in the tank, as it leaves behind vapor and leaves behind the unburned portion, which is resin and varnish. However, we don't have time to make that resin and varnish appear, so we're going to actually introduce a little bit of sulfuric acid here to age the fuel to mimic that oxidation process. Okay, so we take acid and we add it directly into our just gasoline here. We're going to make 2 tubes, of course, to test both products, and we're going to show you what we can do with this product right away. So by introducing the acid there, what we're going to do is we're going to age this fuel to mimic that oxidation that we're used to seeing with old fuel tanks, old fuel pumps that we've taken out, even fuel lines, and we see that restriction and that sticky brown substance. And you know what I'm talking about. So to visualize it, what we show is that sticky brown stuff here on the napkin, on the paper towel, is that oxidized resin and varnish that we're seeing on a regular basis. So we see it within the tube here. You can see a haze within that tube, and you see that resin and varnish down sitting at the bottom. What happens is, as gas is burned off in normal operation, of course the resin and varnish that are left behind don't get burned off, and they leave a sticky layer in the fuel system, and that's like that honey sticky goop we like to call the cholesterol of fuel systems, right? We're used to seeing this all throughout our fuel system as the car ages. When we go to change a pump, change a fuel line, it's there. Okay, now to show you properly, fairly, what the product is you're using right now that helps clean this, or says it helps clean it, which is seafoam, we're going to age the other tube just as equally, same amount of fuel, same amount of acid. Okay, we're looking for the same result, so we don't want to be unbiased here. Still sticky resin and varnish, right? coated tube, fuel, resin, okay? The leftover remnants of unburned fuel being resin and varnish, and we have a nice sticky tube, just as we have with our tube here. So we've got 2 tubes of resin and varnish, okay? So they're equal. So what we're going to show here is the seafoam, okay? We're going to take a fair amount of seafoam, equal amounts. We're going to introduce it to our tube here. And we're going to see what seafoam does to resin and varnish. It says it cleans the injectors. Let's see if we can be fairly cleaning. So right away we can see there's still that goopy haze of resin and varnish through the tube. But the problem is the resin and varnish that it does wash down because it's stripping what it can off of the walls of the fuel line. That resin and varnish is now sitting at the bottom of the fuel system. So this has to be pushed throughout the fuel system somewhere. It could foul an injector, damage a sensor, possibly cause exhaust damage to the cat, because you've got a portion of resin and varnish that will not break down. Even when you shake it up, you see particles just sitting and forming at the bottom of the fuel system. Not a good thing. So this isn't going to do much for us in a way of cleaning. Still leaves a nice thick haze on the fuel system. So not taking anything into account except for what it can actually flush out. Okay. Now with our fuel system cleaner, we want to make sure that tube is nice and coated, just as it would be through the fuel system. Okay. So we've got that nice haze there. What happens with our product is when you introduce it, because of the basis of CTL, coal to liquid technology, the fuel cleaning agent, plus the detergents we have in there and nanotechnology, this product will actually break down on a molecular level the contamination, the resin and varnish, the carbon buildup that will block the injectors, restrict the fuel flow, and clean up those lines. So right away on contact alone, we can see 1/2 of that tube is completely clear. If you can see that. Now the difference is when our product is introduced, even with the amount of resin and acid in here, I'm not worried about moving this back and forth because we do a molecular breakdown, and you can see that tube is completely clear of all the resin and varnish. Nice clean fuel system, clean fuel delivery, no resin and varnish sitting at the bottom of the tube. What happens is it breaks it down on a molecular level. So you don't actually have a flushing through the engine, you have a cleaning. Fuel system cleaner. There's a reason we're called a cleaner, not a flush. This is what we do, and this is why you have a fuel system that is clean, stripped of all moisture, lubricated, all resin and varnish broken down on a molecular scale to burn out in normal operation, safely passing through all filters, sensors, exhaust, everything clean operation. And that's how we get a clean fuel system, gentlemen. So you can have resin and varnish problems, or we can have a nice clean fuel system, clean fuel burning. Okay. So that concludes our demonstration. Is there any questions, gentlemen?
The other car?
Okay, great. So,
The tubes? The first tube. Still emulsified.
still emulsified in our actual fuel system, clean with the water. And of course we have our seafoam next to it, which won't emulsify any water at all. So that lubricating film will stay there and emulsify that product, making sure it burns out in normal operation. Okay, so that concludes the visualization and test tube theoretical portion of our demonstration. We're going to get to our vehicle now. This is run for 15 minutes with the engine oil system clean in there. Okay. We've just got a few more minutes to actually let it run. We're going to complete the process.